Hello and welcome to Sudoku. Here is a Sudoku puzzle by my good friend Glum Hippo. It's an average arrow Sudoku with two thermometers. Well, actually, it's mainly an average arrow Sudoku puzzle, and those thermometers are here to help push the solve forward, I think. I already solved this puzzle, but at the time where I'm shooting this video, it was 3 months ago, so I have virtually no memory of that prior solve. So the rules. We have no standard Sudoku rules, and then those thermometers mean that the digits strictly increase from the board to the tip. So here it's just an inequality. This digit is smaller than this one, and there are 5 digits here, so it will just be used at some point in the solve, but that's not the big deal. The big deal is with all the arrows, and it's not the standard arrow Sudoku. In the standard arrow Sudoku, the digit in the circle would be the sum of the digits along the arrow. But here it's not the sum, it's the average value. It's the mean value of all those digits. And this first row is definitely the place to start, because this being the average of those means that the sum of those digits is 5 times the sum of this digit, 5 times this digit, so that's a multiple of 5. And as we are all aware of, more or less, the sum of all digits on a row is 45, so that's a multiple of 5. So the remaining 4 digits have a sum that is a multiple of 5. But the sum of those 4 digits also is a multiple of 4, because the sum of those digits is 3 times this digit, so the sum of those digits is 4 times this digit. So this sum of 4 digits is both a multiple of 4 and of 5, so it's a multiple of 20, and, well, it has to be 20. Basically, it wouldn't be 40, that would be too much. So this is, those 4 digits have a sum of 20, so this is a 5. And those have a sum of 25, so this is a 5 as well. And now there are multiple ways of having this work, but not that many, because yes, there are a lot of ways to do 15 with 3 digits without using a 5. Now there must be a 5 somewhere here, and it won't be there. 5, 6, 7, 8, 9. Oh, it could happen actually. 5, 6, 7, 8, 9. Well, we've seen in due course, I guess. Now this arrow, there must be something about it. So we know that this is the average value of those, so the sum of all 6 digits is a multiple of 6. It's 6 times this digit. And now the sums of 6 digits, the possible sums of 6 digits are between 21 and 39, And if you take multiples of 6, the only possibilities are 24, 30, and 36. But 30 would make this a 5, which would conflict with this one. So the sum of all those digits is either 24 or 36, and this is 4 or 6. Now there seems to be something along the same line here. This all arrow, including the circle, has a sum that is a multiple of 5. With 5 digits, the sum is between 15 and 35, making this between 3 and 7. Well, that leaves a lot of possibilities. But then, what about this? Now, let's consider all those different possible sums. Because on this row, the total sum is 45 again, and this is a multiple of 3. And so we need to put a multiple of 3 next to this multiple of 5. Sorry. And this digit. And what I'm thinking is, if this is 35, then we need to have those be 1, 2, 3, 4 in some order. So if this is 35, it means that we have 7 here and 5, 6, 8, 9 there. 1, 2, 3, 4. And if you take 3 digits among 1, 2, 3, 4 and take their value, their average value, then the average value must be here. 2, 3, 4 have an average value of 3, and it would repeat. So the important fact here, the point I'm making, is that the sum of those 4 digits must be a multiple of 4 with 4 different digits. And I should be focusing on that. Multiple of 4 with 4 different digits. So it must be between 10 and 30. Multiple of 4. So it will be at least 12, at most 32. 28 actually. So this one is between 3 and 7. So this sum of 3 digits is between 9 and 21. And the possible sums are those. And now we need to have one of those sums here, one of those sums here, and what's left to reach 45 here. Maybe I'm overcomplicating things, but that seems a sensible way of tackling the matter. So what can we have? Well, 9 with, well, this 35 could only take 9, but with a 1 here, and 1 will never be the average value of those. So I think that 35 can be eliminated. 15. 15 with any of those sums, it would not be enough for a leftover single digit. Only this one would work, but that would make this a 9, and 9 will never be the mean value of those. So I can rule 15 out as well. So this is either 4, 5, or 6, and this is not 5. So this is 4 or 6. And now let's have a look at how they can work together. 20 with 21 would make this a 4 and this a 4 as well. So 20, 29, that's a no. 20 and 18 would make this a 7. That would work. So let's say 18, 20, and 7. That is a serious option, and it would make this a 6. Oh, 25 is not an option. Now, those would be not enough. 30 would not work with those. With this, we would have a 6 here and there, but 30 could work with the 12, and that's kind of the complementary option. So we would have 12 with 30 and 3. And guess what? Those options make this a 4 or a 6. I'd say a 6 or a 4. There's some correspondence here. If this is a 4, then obviously this one has to be a 6. That's 18, making this a 4, and this a 7. And the other option, the right-hand scenario, when this is a 6, then this is a 4. We have 12 here, we have 30 here, and a 3 there. And we have to disambiguate this. Now 7 or 3 as the mean value of those 4 digits is very, well, this won't be an issue, but there has to be some restrictions. 7 would make the sum 28, which is a lot, and 3 would make the sum 12, which is not a lot. Then, well, where should I look next? Perhaps I should focus on the possible decompositions, because let's have a look at this 6. We need to have 18 as the sum of 3 digits without using 4, 7, or 6. Oh, or I should focus perhaps on those 2 digits. On the left-hand scenario, we have 24, 30, and we have a sum that is 15 without using the 6, so that's 7 and 8, and 7 doesn't go here. So in this left-hand scenario, we have an 8 here and a 7 there. And then 15, so those 2 digits add up to 8 without using 7 or 5, so they must be 2 and 6. 7, 2 and 6 in the left-hand scenario with the 4. Then with this 4 and this 6, that's 36. With 4, that's 40, with a remainder of 5, not using the 4, that has to be 2 and 3 does not go here, so that's a 2, and that's a 3. There's some kind of complement to 10 everywhere, and in this case, I guess they will be 8 and 4. Well, we need another 12 without using 3 or 5, so that's 4 and 8. So if this is a 6, then we have 3 with 8 and 4. Nice. So 4 and 6 are in these cells in both cases. And here, what happens here? In the first case, 6, we need another 10 without using 8, 4, or 7, so they need to be 1 and 9. That's it. So I think I can remove those. So 6, make this 8, 1 and 9. Sorry. And 4, we need another 10 without using 2, 6 or 3, so there must be 1 and 9 in both cases. And around here, well, the remaining digits, I guess, that is 5, and those that are not in the scenario. What is the next step? 1, 5, and 9 must all be here, but 1 and 9 are not there. Where should I look? This looks like a nice place to look, but it's not related to anything we've seen up till now. Oh, there was something about 5. I said there could be 5, 6, 7, but no, 6 is in those cells, so that won't be a 5. So 5 is in one of those cells. Maybe I should look at this. This is the average of 4 values. It won't be 5. It could still be 4 or 6, but could probably be something else. Would 3 work? Well, 2 wouldn't work, because if I make this a 2, that's a minimum of 1, 3, 4, which is 8, and this makes the sum larger than 8. So 2 wouldn't go, and by symmetry 8 wouldn't work either, but I think 3 is a valid option. I can make this 12. That's a minimum of 1, 2, let's say 1, 2, and 4, and 5. That would work. And you could even have something like 2 and 2, and 1 and 7. You could also have this. So this is between 3 and 7. Now, this must be the mean value of those 5 digits, but they need not be all different. But that's a minimum of 10, so the overall minimum is 11, and actually those 5 digits have a sum that is a multiple of 5, so that's a minimum of 15. So this has a minimum of 3 and a maximum of 7 by the symmetrical argument. And that leaves a lot of freedom. A lot can still happen. Well, what will be the next arithmetic stuff? Oh, let's recall something. 1 and 9 are not on this. 1 and 9 can't be in the middle of a thermo. So 1 and 9 have to be somewhere in those cells. So this is a 1, 5, 9 triple. And 9 obviously can go here. So this is a 5, 9 pair. And that's a 1. Nice. Now I guess that 7 is not an option, because now the maximum value for those three cells, the maximum sum is 189, that's 18. So the maximum value here is 6. And 5 is not an option. So let's say 3, 4, or 6. Well, obviously 1 is not a big restriction on this. But this is a 5-9 pair. And let's have a look at this thermo. This is at most 9, 8, 7, 6. And 6 is not available, 5 is not available, 4 is not available, so it has to be 2 or 3. And let's say 9, 8, 7. 7 is possible, I guess. But not 4, 5, 6, not 3. So this can only be 3 or 7, I think, which would make this a very nice pair. But let aside, well, what's the correct way to say that? Well, just not taking into account the fact that those are the only options, we can see that 8 would never go on those cells. So 8 has to be on the arrow, and we now know that the correct scenario is the right-hand scenario. So I just leave that for the moment, and we know that this is a 3, that's a 2. This is a 4-8 pair. That's a 6, that's a 4, that's a 2, that's a 6, that's a 3. And this is a 7, just by regular Sudoku. And those are 8 and 9. So this thermometer was really put there to help us, well, advance the solve. Now we have all those digits. There are 1, 2, 7, 6, and 9. And we have all those digits as well. There must be 1, 5, 7, 8, and 9. All those 5 digits, but this one is not 1 or 9, so it's 5, 7, or 8. There's a 1 here. 1 would have a very nice place here, but I doubt that we'll use that right now. So where should we look next? Oh, this 6 make this not a 6. Now, where will 9 go? Oh, well, 8 will go there. But can 9 be here? Or do we have an 8-9 pair here? Well, with a 3, that wouldn't work. With a 4, could it work? Let's assume this is a 4 and this is a 9. We need to make those add up to 16. And no, that wouldn't work. But that would work. So 9 can go in this cell. What are those digits? There must be 4, 5, 7, 8. So not much here. What about this cell? It's not a 7. So the remaining candidates are 3, 5, 6, and 8. But 8 is not very likely, because none of those 3 cells can have a 9, so 8 is impossible. This is 3, 5, or 6. Three doesn't sound very likely either, because this is at least 5. Oh, actually it would work with 3, 5, 1, and 3. So there's no reason to rule 3 out. What about those? Well, there are a lot of options. If this is a 3, then those must have a sum of 8, and 2 and 6 would work. With 4, we have plenty of options, 5 and 6, for instance. Bobbins. Well, those 4 digits have a sum of 12. But there are a number of options. You can have 1, 5, 2, 4, 1, 5, 1, 5. Not seeing what I can do here. Should I focus on this, on that, on that? Oh, I've missed this. This one makes this elimination. So there's a 1 here, big deal. There's a 9 somewhere in those cells. That's not very useful. There's a 2 somewhere in those cells, but 2 here would work with a 6 here and a 3. 2 here. This, well, I don't know. Oh! There's a 9 somewhere on this column. It's not here, it has to be there, but 9 won't be the mean value, so that's a 9. Oh! And this is really nice, because now those 2 digits must have an even sum, so this is an odd digit. So it has to be 3 or 5. But it can't be 3, because it would make this a 6, so that's a 5. And we get a 7 here. That was unexpected. So this is not a 5. And what else do we get? So there's no 7 here. 7 has to go there. Those are 4, 5, 8, but something tells me that 8 is not a likely candidate for this. Because with 8, I would need a sum of, let's say we put an 8 here. We would need a sum of 24. There would have to be a 9 along the arrow. Not here, but here. And those should have a sum of 15 without using those digits, and that wouldn't work. So that's not an 8. So it has to be 4 or 5. This is 4, 5, or 8. On this column, we still need 1, 2, 3, and 4. So here, those are small digits. And can this be a 6? I get the feeling that we get only small digits on this arrow, which make this average of 6 very troublesome. This is at most 4, or this can still be as high as 8. With 8, 4, we would need another 6 to reach this 6, but we can still have an 8 here. With 8, 8, and 2, we get an average of 6. So 6 is still possible. We need to put 1, 2, and 3 in this space, but that's not saying much. Where should I focus? We don't have a 5 here. 5 is either here or there. But there's still 1, 7, 8, 9. This is not 9, that's 1, 7, or 8. This is not a 9 either. Nine can still go here or there. 9 here would make this a 5. Well, that's not very interesting actually. There's a 2 somewhere in one of those cells. Already said that, I think. I'm going in circles. So there's still the issue of where 9 goes in this box. It's not here, it's not there, it has to be in one of those. 9 here would work very well, but here I stated that it was a possibility. But then, what about this 3? I get the feeling that there are not lots of places for 8. 8 wouldn't work on this, or it could. 8, 1, 2, and 1. Bobbins again. There's a 7 around here. I get the feeling that I didn't struggle so much when I solved it the first time. But then, having no precise recollection of it, that's not something I can certify. On this row, 9 is either here or there. It really wouldn't work here. It would require a triple 1. Well, a sum of 12 or 15 is really not constrained. Is 3 a valid option? That's a minimum of 6, if I make this a 3, and with 1 and 2 here it works. Except that 1 and 2 here is not an option because 1 and 2 are in this column. So I think that 3 is not possible here. because 6, 1, and 2 would be the absolute minimum. Yes, I think that's it. So 3 is eliminated from this cell. So that's a 6. And we need a sum of 18. And that doesn't seem to be so many options. 2 is here, so this can only be 3 or 8. All other digits have been eliminated. One, yes, those 5 digits and this 7 and this 5, so only 3 and 8 are possible. What about 3? If this is a 3, then those must have a sum of 15, and with all those digits in this column, that's not possible. So this is an 8. And up there, that's a 5, that's a 4, and that's an 8. And we get a 2, 3 pair. Now, those must have a sum of 10. That's a small digit, that's a big digit, and that's not a 9. So the options are 2, 3, 4 together with 8, 7, and 6. And there's a 1 up there. Those now are 5, 7, and 3. This is 3 or 5. And 1 and 8 are both here. There has to be a 6 somewhere. And now we have very few options for this arrow. And I think 4 is no more an option, because those would add up to 11, making this 8 or 9, but none of them is available. So that's a 3. Now those must have a sum of 8. So this is 6 or 5, and both are still possible. Oh, there's a 5 here, sorry. So that's a 6, and that's a 2, and that's a 3. So there's a 4 somewhere in those cells. This is 1, 7, 8, or 9. Well, 7 or 8 here would make this a 9, and this a 4. Not sure what to make of it. But now that this is a 3, I think this can no longer be a 9. Yes, of course, the sum of those 4 cells is 12. And 1 around here is probably mandatory. So 9 can't go here, so 9 is up there. If I don't put a 1 here, then the minimum here is 4 and 8. No, actually nothing is available. The 9 goes there. So that's an 8, 9 pair. And we get 1 and 4 here. So that's 5. We need another 7 here. The available digits here are 2, 6, and 7. So this is 2 or 6 together with 5 or 1. those are, well, there's a 1 and 2 digits among 2, 6, and 7. 3 is not here. 3 is in one of those. This is 2, 4, 6, or 7. Lots of choices. Oh, but there's a 1 here, so this is not a 1, that's a 5, and that's a 2. What do we get from this? Oh, this 6, 7 pair makes this an 8, so that's a 2. Oh, that's the very option I considered at some point. Now this is a 1, 4 pair. I need to charge my device. Well, charge as a verb, that doesn't sound right. Maybe it's missing a preposition. Anyway, those are 3, 7, and 6. And because of this, that's a 3. And that's a 6, 7 pair. And this is not an 8, so we get a 4, 5 pair. And those are 7 and 8. And I'm using this one. This 1, 7. Here, the digits are 1, 2, 3, and 8. So this is 1 or 2, 1 or 3. 8 goes here. This is 1 or 2. Yes, that's correct. So that's a 4, that's a 1, that's a 3, that's a 5, and that's a 4. That's not a 3, and that's a 3. I think this is correct. Then, the sum here must be 12. So the sum here must be 4 without using a 2. So that's not 2 plus 2, and because of this 3, that's a 1 here and a 3 there, and a 3 up there. 4, 6, and 7 here. We'll have a look at it later. Those 4 digits have a sum of 12, so this plus that must be 8. So this is that is a 6, and that is a 2, and this is all consistent with those digits. Now we're missing a 5, so 5 goes here. That's a 9. And we get 4 and 6. That's good progress. So 4, 6, 7 here. We still need a 1 and a 2 up there. We don't have them yet. We'll still have some work to do with this 7. That's not a 7. Where should I look? This row. This row needs a 1. It can be here or there. 1, 4, 7, 9. That's not very useful. This column needs 2, 4, 6, and 9. This is 2 or 6, 2 or 4, 4 or 6. Oh yes, I could have focused on digit 9. It could. Why could 9 not go there? No, that was not right. 9 is still a candidate in this cell. There must be a 5 here by Sudoku. Where will 8 go? 8 will go in one of those cells. And I'm thinking I could start working on this. The sum here is 35. And there's already a 5, so the sum of those 4 cells must be 30. 4 here wouldn't work. We would need those 3 cells to add up to 26. So this is a 4. That's a 6, that's a 4, that's not a 4. 4 here wouldn't work either. We would need those to add up to 26, so that's not a 4. And I think 9 is mandatory here because the maximum here is with 8, 6 and 7 because of this 9, and this makes this a 9. Yes, the maximum is 9 here. That's a 4. Those are 6, 7, and 8. So this is a 1. So this is 7 or 8. This is 6 or 8. This is a 2. That's a 6. And, and there's a lot of deductions going on. This is a 7, and up there we get the 1 and the 2. All right, just for the last adjustments, this is not a 4, that is a 4. So this is a 1, that's a 4, that's an 8, and this is obviously a 9. And this is a 7. Oh, I see. Without this thermo, there would be some deadly pattern with those cells. Okay. So this thermo is there to ensure uniqueness of the solution. And now, 48 minutes. Oh, that was much more difficult than what I seem to remember. I'm just typing the solution code on Logic Masters Deutschland to register my soul, and my code is correct. So the difficulty, I'd say 4 stars. I had said 3 stars in a previous rating, but I've changed my mind. This was really hard, and it was obviously very nice, as usual, with my Hippo Friends puzzles. Well, that was a pleasure. That was quite long too, but really, really, really a fun variant. Thanks for watching this video. See you soon on Sudoku.